We are now moving on to week 6 of quarter 1, wherein we are going to focus on polynomials. So our objective for this video is to perform division of polynomials using long and synthetic division. So since we are going to perform division of polynomials, let us first have this concept on how are we going to express the quotient. So if P of x is the dividend, D of x is the divisor, Q of x is the quotient, and R is the remainder, then P of x over D of x is equal to the quotient plus the remainder over the divisor. Or we can simply just express the dividend as the product of the divisor and the quotient plus the remainder. But for the sake of our class, we are going to focus on our first notation. Why is that so? Let us have this logic. 5 divided by 2. We know that this is 2.5, which is equal to 2 and 1/2 if we express this as a mixed number. And 2 and 1/2 we all know is equal to 2 plus 1/2. So let us use long method on 5 divided by 2. So we have here 5 divided by 2. So we have here 2, and then we multiply 2 and 2, we get 4. We subtract and we get 1 as our remainder. So if you are going to express, we have 2 and 1/2. We have here 2 as our quotient, 1 as our remainder, and the other 2 as our divisor. Same is true with this notation. So we have the quotient plus the remainder over the divisor. This is the notation that we are going to use. Let us have our first example. So we have to use long method division in dividing 3x cubed plus 19x minus 10 plus 16x squared by x plus 3. So the first step that we are going to do is to check our dividend. There are two things that we should check on our dividend. First, is it in standard form? And second, does it have a missing exponent? So let us check first if our given dividend is in standard form. When do we say that a polynomial is in standard form? If it is in decreasing order of exponent. So we have here exponent 3. And the second term is exponent 1. So needless to say, it is not in decreasing order of exponent. So we are going to express this first as a polynomial in standard form. So we will have 3x cubed. We will write here 16x squared. So as it will be in decreasing order of exponents. And then we have 19x minus 10. This is our polynomial in standard form. So as you can see, we are now in decreasing order of exponent. 3, 2, exponent 1, and then our constant term. So this is now a polynomial in standard form. Next thing that we are going to check on our polynomial is that, does it have a missing exponent? So obviously, it does not have a missing exponent because all our exponents are complete. We started from 3, we have an exponent 2, and then we have an exponent 1. So we did not skip an exponent. So this dividend is now good for division. And then we are going to divide this by x plus 3. So the first step in our division process after checking is to divide the first term of our dividend by the first term of our divisor. So we will have 3 x cubed divided by x. So there are two things that you can do here. You can simply just subtract the exponents. So we have 3 minus 1, we get 2. So that's 3x squared. Or you can simply just cancel one of the x's here. Cancel everything here. And then we also get 3x squared. So this is the first term of our quotient, 3x squared. So after dividing the first terms of our dividend and divisor, we now multiply this quotient by the two terms of the divisor. So we multiply this to the two terms of our divisor. Sort of like distributing. So we have now 3x squared times x. So we have 3x cubed. And then 3x squared times 3. So we have plus 9x squared. After doing so, let us change the signs. So this is a positive, we have a negative now. And this is a positive, we have a negative now. And then, after changing the signs, we add. So if we add these two, obviously they cancel out. And then we have 16x squared minus 9x squared. So that is 7x squared. And then we bring down the next term, 19x. So plus 19x. And then we just repeat the process. So we have 7x squared now divided by x again. So 7x squared divided by x. We cancel one of the x's here, cancel everything there. So we are left with 7x. So that is the second term of our quotient, 7x. So plus 7x. And then we multiply 7x to both terms of our divisor, sort of like distributing. So we have now 7x times x, we get 7x squared. And then 7x times 3, we get 21x. So plus 21x. And then we change the signs. This is a positive. This will be now negative. A positive will become negative now. And then we add. So we cancel this. And we are now left with 19x minus 21x. So this is now negative 2x. And then let us bring down negative 10. And then repeat the process. So we have now 2x divided by, negative 2x divided by x. That is negative 2. And then this negative 2 right here, we are going to multiply to both terms of the divisor. So we have negative 2 times x, negative 2x. Negative 2 times 3, that is negative 6. We change the signs. So from negative, this will be positive. From negative, this will be positive. And then after changing the signs, we add. So we have now, these are obviously cancelable. And then we have negative 10 plus 6, that is negative 4. Since we do not have any other terms to bring down, this will be our remainder. So how do we express now our quotient when 3x cubed plus 19x minus 10 plus 16x squared is divided by x plus 3? So our final answer will be 3x squared plus 7x minus 2, that is the quotient, plus the remainder, that is negative 4 over the divisor x plus 3. Or Siguro we can have negative minus 4 over x plus 3. Something like this. So let us now go to our second example. We are still going to divide this polynomial by x plus 3, but we are now going to use synthetic division. So again, let us express this in standard form, and we all know now what the standard form is. This is 3x cubed plus 16x squared plus 19x minus 10. So this is our standard form, and then we are going to divide it by x plus 3. Now, what we are going to do is to change the sign of the constant term. So if this is positive 3, this will become negative 3. So let us put that negative 3 in the division box. After so, we are going to copy all numerical coefficients of terms in the dividend. Just the numerical coefficients. So we have here 3, we have 16, we have 19, and negative 10. And just proceed to our synthetic division. So first thing that we have to do is to bring down the first term. So this is going to be 3. And then we multiply 3 times negative 3. That is negative 9. And then add. So we have 16 minus 9. That is 7. Continue the process. 7 times negative 3. So we have negative 21. And then add. That is negative 2. Negative 2 times negative 3. That is positive 6. And then add. That is negative 4. The very last term in this process, that is our remainder. And everything here, these are the numerical coefficients of the terms of the quotient. So what will our final answer be? Let us take a look at the degree of our dividend. What is the degree of our dividend? When we say degree, it is the largest exponent when the polynomial is in standard form. So basically, it's just the first exponent when it is in standard form. So that is 3. We subtract the degree of the dividend and the degree of the divisor. What is the degree of the divisor? The largest exponent here is just 1. That can be. Pwede yun. So we have now 3 minus 1 is 2. 2 is the degree of the quotient. So here, we have an exponent 2. So this is the numerical coefficient and exponent of 2. And then just continue decreasing the exponents. So this is a positive 7. So plus 7x. Just an exponent of 1. And then this is the constant term. How do we know? Because we have a previous term of an exponent 1. And then minus 4, the remainder, over the quotient x plus 3. If we compare our answers, we would know that this will produce the same answer right there. As you can see, we have the same answers. So this is our synthetic division. Let us now go to our third example. So we have to divide x to the fourth plus minus, x 3x cubed plus 2x minus 2 by x plus 2. And we are going to use long method. Let us check if it is in decreasing order of exponent. 4, 3, 1, constant term. Yes, it is in decreasing order of exponent. But the second thing that we have to check is, does it have a missing exponent? Yes, it does have a missing exponent. We are missing an exponent too. That being the case, we have to use a so-called filler. when we perform our division. What does a filler look like? So we have now x to the fourth minus 3x cubed. Since we have a missing exponent 2, we can simply just leave a blank here. So we know that that is our exponent 2 plus 2x minus 2. Or in some cases, if you don't want to get confused, you write 0x squared. I personally prefer that to be just blank, but you can write 0x squared there. So you'll know that you should have a term there with an exponent 2, but you do not have a term of exponent 2. So you write a 0 numerical coefficient. So that's just basically 0, but with an exponent 2. Okay? So let's have now our division. We will divide this right there by x plus 2. So again, the first term of the dividend, divide it by the first term of the divisor. So we have x to the fourth over x. So you cancel that, cancel everything here, and you are left with 3x's. So that is x cubed. Let me just erase this. And then, after dividing those two terms, the quotient of that, you will multiply to both terms of the divisor, sort of like distributing. So we have x cubed times x, that's x to the fourth, and then x cubed times 2, that is positive 2x cubed. Now, let us change the signs. So this is a positive, this will become negative, also a positive, this will become negative, and then we add. So we have now cancelable terms here, and we are left with negative 3x squared minus 2x cubed, both negatives. So that's negative 5x cubed. And then bring down the next term. Even if it is a filler, you bring that down. So that is plus a blank. Or you can write your 0x squared there. That can also be. And then you repeat the process. So we have now negative 5x cubed, negative 5x cubed over x. So we can cancel 1x in the numerator and cancel everything here. So we are now left with negative 5x squared. We write it here. Sorry, that is negative. So that's a minus 5x squared. Now that we have divided those two terms, let us now multiply this term to both terms of the divisor, sort of distributing. So we have um, negative 5x squared times x, that's negative 5x cubed. Then negative 5x squared times positive 2, that is that's negative 10x squared. And then we change the signs. So this is a negative, this will become positive. This is a negative, this will also become positive. And then we add. So if we are going to add, we will have cancelable terms here. And now we have here 10x squared. Let us now bring down the next term. Or I forgot to write the arrow here. So we have here plus 2x. Then just repeat the process. We will now have 10x squared right here. We will divide it by the first term of our divisor. So we cancel one of the x's here, cancel everything here, and now we are left with 10x. So we have plus 10x. Now, after dividing, we are now going to multiply this term to both terms of the divisor, sort of distributing. So we have 10x times x. So that is 10x squared. 10x times 2, that is 20x. Remember that whenever you multiply, you add the exponents, because whenever we divide, we subtract the exponents. So let us go back to our solution, change the signs of the terms here. A positive will become negative, so as this, and then we add. We have cancelable terms, we cancel those, and then let us add 2x minus 20x, that is negative 18x. And then bring down our last term, which is negative 2. So this will become a minus 2 here, and then repeat the process. Negative 18 divided by x. So we have negative 18x divided by x. Cancel the x's. We are left with negative 18. So negative 18. And then, after dividing, we multiply negative 18 to the terms of the divisor, sort of multiplying. So we will have negative 18 times x, that's negative 18x. Negative 18 times 2, that is negative 36. We change the signs. From a negative, this will become positive, so as this. And then we are going to add. So cancelable terms here, we are now left with negative 2 plus 36. This is now 34, a positive. This is our remainder. Let us now compose our final answer. So our final answer will just be the quotient. So I'll just copy our quotient here. Of course, we do not want that. So we have x cubed minus 5x squared plus 10x minus 18 plus the remainder 34 over the divisor. What is the divisor? X plus 2. This is our quotient. Let us have our fourth example, which will be just the same but using synthetic division. So again, we are going to change the sign. Is it x plus 2? Yes. So we change the sign of the constant term of the divisor. So this is going to be negative 2. We put this in our division box. And let us copy all the numerical coefficients of the terms of the dividend. Remember the filler. So we have 1, negative 3. Negative 3 is the numerical coefficient of the term of exponent 3. We do not have an exponent 2, so we write a filler 0. For exponent 2, let me write it so you won't get confused. For exponent 2. This is our filler. Okay? And then we have exponent 1, that's positive 2. And then constant term, negative 2. We are now going to proceed to our division. We have to bring down our first term. That's 1. Times negative 2, that's negative 2. We add negative 5. Multiply it by negative 2, that is positive 10. Add 10. Times negative 2, that's negative 20. Add, that's negative 18. Multiply, that is positive 36. Add, that is positive 34. The last term is our remainder. And then, these are the numerical coefficients of the terms of the quotient. But what is the degree of our quotient? So the quotient will be of degree of the dividend minus degree of the divisor. What is the largest exponent in the dividend? 4. What is the largest exponent in the divisor? 1. So subtract 4 minus 1, 3. That is the degree of our quotient. So this is now a numerical coefficient for exponent 3. So we will now have x cubed. There is our 1, but we do not write a 1 numerical coefficient. And then just decrease the exponents using the numerical coefficients here. So we have minus 5. Decrease the exponent squared plus 10. Decrease the exponent x to the first power. We do not write that. And then this is the constant term, minus 18. Plus the remainder, 34 over x plus 2, the divisor. Let us compare if this is also the quotient that we have gotten here. So we have the same quotient. Therefore, our answer is correct.